All right, we're still factoring trinomials, but this time I'm going to show you the divide and slide method. So for this first example, it says y squared plus 2y plus 1. Remember that anytime you have a variable with no coefficient, it's an understood 1 as your coefficient. So this is 1y squared. And when you use this method, you want to multiply your a value times your c value and then rewrite it as y squared plus 2y plus whatever your new c value would be. In this case, it doesn't change. And I understand that, but I want you to make sure that this is always the pattern that we're doing. We always take this a value and we slide it to the back. We multiply it by whatever it is here. And of course, 1 times 1 is 1. So whatever this number is, we're going to go ahead and list its factors out. So the factors are 1 of 1 are just 1 times 1, or we could have done -1 times -1, right? I want the pair that combines to give me a positive 2. So this is the pair that I would use, this pair right here. So let me go ahead and set up. I know I'm going to have two binomials, and because my variable is a y, that's what each of my binomials starts with. And because my pair is made up of both positive 1s, I'm going to put a +1 and a +1. Now, what term did we slide to the back in the beginning? We slid this positive 1. We always want to divide with whatever a value we started with. So I'm going to divide this by a 1 and this by a 1. And hopefully you see 1 divided by 1 is still just 1. So when we simplify that, we just get y plus 1 times y plus 1. Now this was a very easy and oversimplified trinomial to factor. So let's try it with something more difficult, and it actually might be more obvious in how to use this method. So I changed this problem to 30m squared minus 170m plus 100. Don't be afraid of these larger numbers, because when you look at these, you see that they're all divisible by 10. Hopefully you see that, because they all end in a 0. So let's factor out that GCF first. We have 10 times 3m squared minus 17m plus 10. And now it looks a lot more manageable. So remember, we're taking this a value and we're going to slide it to the back and multiply. So our new trinomial becomes m squared minus 17m plus 30, because we slid that to the back, right? And always bring down your GCF from the beginning. All right, so let's break apart this 30 that's right here on the end. I'll use a different color, this positive 30 right here. So what are the factors of 30 that you can think of? Well, off the top of my head, I immediately go 3 times 10. But I want my factors to combine to make a -17. So would -3 times -10 combine to give me a -17? No, but I could use a -2 times a -15. When I multiply these together, I get a positive 30, and when I add them together, I get this -17, so that's what I want. So I'm going to go ahead and bring down this 10 from the beginning, and I'm going to break my trinomial into its two binomials. I have an m for both of them. And because my two factors are a -2 times -15, I put that -2 and -15 right here. Now we have to undo this sliding this 3 back from the beginning. So I'm going to divide both of those terms by the 3. Now, can I simplify -2/3? No, I cannot. So I don't want to leave this fraction here. So whatever is left over right here slides to the front of this binomial. So I end up with 3m minus 2. And then I look at my second binomial, -15 divided by 3. Well, that reduces to a -5, so I get a whole number right here. So that ends up just giving me m minus 5. I don't have to slide anything forward because, again, this term simplified to a whole number. And, of course, don't forget to bring down your 10 that you factored out originally. So that's how you can use the divide and slide method. or slide and divide. I can never remember which way they call it. Anyway, let's look at one more example. 6x to the fourth power plus 5x to the third minus 6x squared. In this problem, our GCF is just an x squared. So we're left with 6x squared plus 5x minus 6. All right, so let's take our a value and slide it back here. When we multiply, that gives us positive 6 times negative 6, which turns our c value into a negative 36. So this is x squared plus 5x minus 36. Bring down your GCF from the beginning. So let's break this negative 36 into its factors. Negative 36. Well, I can think of negative 12 times positive 3, but I see that I want my factors combined to make this positive 5 right here. So I also could try positive 9 times negative 4. When I multiply those together, I get negative 36, and when I add them together, I get this positive 5 right here. So that's what I want to use. I want to use 9 times negative 4. All right, so bring down our GCF and break our trinomial into its two factors. That's an x plus 9, and of course an x minus 4. Now let's go back and take care of the 6 that we slid to the back in the beginning. So we're going to divide both of those by the 6 and simplify. Well, 9 divided by 6 does reduce, but it doesn't simplify to an integer. So we have to write x squared times x plus 9 divided by 6 simplifies to 3/2. And then, of course, x minus 4 over 6 simplifies to x minus 2/3. So we could simplify the fractions, but not to integers. So of course, whatever denominator is left, we slide to the front in both of these binomials. So we're left with x squared times 2x plus 3 times 3x minus 2. And that's how you can do the slide